All right, so 2 examples left to rock and roll through. So we have Stacy going to middle school. People ride bikes, people walk, or people take a bus. Pause, cube, then proceed. So you should look something like this. Notice that I broke off to the side and rewrote my ratios with what each of those numbers mean, because it's really, really important to being able to do this. We're comparing 3 quantities now, but the way that these ratios are written, we can't just look at them as one big ratio like the last one. We can't just string the 3 pieces together like right here. Not yet. We want to get a common value. And what we see here is that walking shows up with both of these. So if I can get that green ratio, that first ratio, as something to 12, then I can unify this all into one wonderfully glorious ratio. So I need to find an equivalent ratio of bike to walk, 3 to 4, where the walkers is 12. Well, we know we can multiply by 3 to get that, so 9. So our big unified ratio, now that walkers is 12 in this ratio, I can say that we have 9 to 12 to 7. Bike, walk, bus. So these are part to part to part. There's 3 parts to this whole. I could draw a picture again with 9 parts, 12 parts, and 7 parts, but I can identify the total number of units by taking 9, 12, and 7 and adding them, giving me 28 parts that make up this whole. So what we know is that 28 units represent 560 students total. So 1 unit then would be 560 divided by 28, which is 20 students. So each one of these parts represents 20 students. So, how many students ride bikes? Well, to answer that question, we have to remember what ratios we got these parts from. We got the ratios, we got those parts from these ratios right here. Not from the 3 to 4. The 3 to 4 is irrelevant to us now. This 28 came from the 9, 12, and 7. So to get the number of students who ride bikes, we're going to take that 20 students for each one of these pieces, each one of these parts, and we're going to multiply it by 9. 20 times 9 is 180. There are 180 students who ride their bikes. Last example, then you shall go forth and have glorious fun with these ratios. So our problem here, we have Claire. She has green plates and red plates in a cabinet. The ratio of green plates to red plates is 2 to 1, as you see in the picture here. She adds some more red plates, and now the ratio becomes 4 to 5. And she's adding red plates. Okay, so pause, cube, process, then play again. So I've cubed it, and I've changed the picture now. This picture started out as 2 to 1. Well, I want this new ratio to become 4 to 5. I can do an equivalent ratio by multiplying by 2. So the equivalent ratio to the original would be 4 to 2. And then we add 18 more plates. So, and those 18 plates make the new ratio 4 to 5. So I've got my 4 green ones. I'm taking and adding in 18 new red ones. So what we see in this picture now is that 3 units is equivalent to 18 plates. You have to extend the ratio, you have to write an equivalent ratio in a way that you're going to be able to add more of the other thing to get the new ratio that we want. So I took 2 to 1, I can make that 4 to 2, I could have made it 6 to 3, but I needed 4 to something. I needed this 4 to something here. 4. So 4 to 2. And then I need 3 more to reach this 5. So 18 plates is equivalent to 3 units. 1 unit would be 18 divided by 3, or 6 plates. So how many green plates are there in the cabinet? Well, how many units are there for the green plates? How many parts? There are 4. So 4 units times 6 plates each. We have 24 green plates in the cabinet. How many red plates are there in the cabinet at the end? Well, originally we should be able to reason out that, okay, if there are 24 green plates in the cabinet, that means there's going to be 12 red plates. So I could add 18 to it. Or I know that, well, there are 5 units in the picture. 5 units times 6 plates per unit. That's going to be 30 plates. So there are 30 plates in the cabinet at the end. What I was talking about at the beginning was if it's 2 to 1, being green to red, and I know that I have 24 greens, an equivalent ratio that would be 12. So to begin with, before I add the 18, I have 12 red plates. Add the 18 in, now I have 30. There are 2 ways to think about this problem. So there we go. There's the end. I hope that you're seeing that ratios can actually be used for things. This is something that I use, my wife uses, really most of the time when we're cooking. This is used a lot for scaling recipes. I have a recipe that makes it for 5 people. I'm going to have 18 people over for Thanksgiving. How much of all this stuff do I need? That's ratios, ladies and gentlemen. So, with that, I leave you.